So for the neutralization reaction, it is a reaction, as you see or you expect from the name. It is something neutralizing something else. So you have two opposite or different types of compounds that have different properties, and they get to be or get to a neutral point when they're put together. So it is the reaction between an acid and an alkali. It's a low pH with high pH to give a salt which has a pH of around 7. So the very famous example is sodium hydroxide plus HCl will produce sodium chloride plus water. This reaction, this video is a good example of this reaction. So here we have the HCl and sodium hydroxide. He's gonna put what's called an indicator. An indicator is just a compound that's put in the solution, and its color changes with the pH, according to the pH. So here for the acid, this indicator, the color of the indicator is red in acid and is kind of purple in base or basic solution or alkaline solution. So you can easily tell even without knowing what's going on that this is acidic, and it said the pH equals smaller than 3. So when he mixes them together, the color changes from red and purple into green, which is the neutral. So the pH now is 7, which is the color of the indicator turns green when the solution or the medium is neutral. So this is what happens. The pH turns to be 7 when the acid and base are strong. This is like what we see here. HCl is a strong acid, sodium hydroxide is a strong base. In some cases, you would have a strong acid with a weak base or a strong base with a weak acid, and in this case, I'd expect the salt will not be very neutral. It will be closer to the strong part. So if you have a strong acid and weak base, then the salt will be kind of acidic, and the pH would be smaller than 7, and the other way. And this is something that we will gonna discuss in details in the last chapter in this course, inshallah. So the fourth reaction is the hydrolysis. Before we talk about hydrolysis, I want you to understand the difference between two things. When you have a salt like NaCl, which is an output of a reaction of a strong acid and a strong base, like the previous video that we just watched, the salt will, when it's in the water, it turns to be sodium ion and chlorine ion. And here I want to talk quickly about one thing that is important for you to know. Is usually when you have a reaction, it is a reversible reaction, or all reactions are reversible. So for NaCl plus water gives Na and Cl. I would expect this to produce NaOH and HCl, but for the case of NaCl, the sodium, this reaction, I'm going back here, this reaction is extremely fast, and the sodium hydroxide and HCl are quickly go into reactions to form the sodium chloride. So the speed of the reaction going in this way is way faster than the speed of sodium chloride going back to sodium hydroxide and HCl. And that's why we never see HCl and NaOH in a solution. They react quickly to form the salt and water. I wouldn't expect this to produce NaOH and HCl because the backward reaction would be very fast. But what happens is that the salt starts to ionize, and this means that the sodium ions and chlorine ions are gonna be floating in the solution. Not sodium hydroxide, not HCl, but sodium ions and chlorine ions. But what happens in case of strong acid or salts that are formed from a strong acid and a weak base, or the other way, is what's called hydrolysis. And hydrolysis is the formation of the original components that form this salt. So we have sodium acetate here. When it reacts with water, it produces acetic acid and water. Acetic acid is a weak acid. and water, and sodium hydroxide. So acetic acid is a weak acid, so the reaction between sodium hydroxide and acetic acid is not as fast. So you can have them in the solution um, present in when the sodium acetate is present in or is diluted with water. So this is called hydrolysis and or hydrolyze. What we mean by the salt hydrolyzes that it forms the original acid and alkali that form the salt. But here we say ionize because it forms only ions, not the total compounds or the full compounds. The fifth reaction is called the displacement reaction, and it's clear from the name that something is going in the place of something else. So this can have different forms. One of them is displacement of metal by another metal. So if you put a metal in a solution of another metal, it can kick this metal out of the solution and be part of the solution. Um, and the thing that tells us which metal can replace or displace the other metal is the electrochemical series, which is a list of the elements. They are arranged or sorted according to their chemical activity. So as we go down as the activity decreases, so the elements in the top can displace the elements beneath it. So lithium can displace all the elements below it. For instance, calcium, where's calcium? Calcium here can displace sodium, magnesium, aluminum down to gold. But calcium cannot displace barium, cannot displace potassium, cannot displace lithium. Um, I just want you to take a look at copper and silver. So copper can displace silver, but silver cannot displace copper. So this is like another video for the displacement reaction. And what happens here is we see the copper. This is a copper wire. It is put in a silver nitrate solution. This is the copper wire. It's put in silver nitrate solution, and this reaction takes place. The copper is displacing silver in the solution, and silver is dissolve or is precipitating. And this is what we see here. You'd see that this is the copper wire. The silver starts to form here, and the solution was not originally blue, but it turns to be more bluish because of the formation of copper sulfate in the solution. Um, and you see silver gets more and more precipitated, its weight increases, and it deposits. And now the video is speeded up, and you see that the silver is precipitating, and then when the copper is exposed, more silver is precipitating, and the reaction proceeds spontaneously. I didn't put any voltage, I didn't put anything to speed up the reaction, it just happens spontaneously. Um, so this is for the displacement reaction. It can happen between a salt and an acid. So an acid like sulfuric acid can displace the radical here in its salt solution. So sulfate in the acid can displace the nitrate in um, the salt to form the reaction. The acid reacts with sodium nitrate to form sodium sulfate and nitric acid. And in this case, we have to understand that before, in the case of metals, we said that the metal has to be more reactive than the metal that is displaced. And here, the same thing, that the displacing acid has to be more stable than or stronger than the displaced one. Sulfuric acid has to be more stable than nitric acid. And this is something that people usually do in the in organic chemistry labs to test for the salts. So if you want to know the negative ion in the solution or in the salt, you have to do series of reactions or series of tests. You first do the reaction with dilute hydrochloric acid, and if it works, then you know that this is one of some acids, carbonates or bicarbonate or something. If it doesn't react with HCl, then you go for sulfuric acid, and if it's sulfuric acid, then you know it's chlorine, bromine, iodine, or something like that. And this is this sequence is done because the salts have different activities. and not all the reagents can react with the salts, and this is the same thing. You have here sulfuric acid is stronger than the nitrate, and that's why it can displace it, but nitric acid cannot displace the sulfate because it's not as strong as it. And again, the same thing that we mentioned before applies here. The reaction can go in forward and backward directions, but the forward reaction is faster, a lot faster than the backward direction reaction rate, and that's why the reaction proceeds in this direction. The last reaction we're going to talk about in this video is the precipitation reaction, and the precipitation reaction is kind of similar to the displacement reaction, with only one difference, is that one of the outputs is precipitating, and this is easy to predict from the name. We have something that comes out of the reaction that precipitates, which means that it comes out of the solution and falls down to the bottom of the beaker or the test tube or whatever. So see, for instance, here H2S plus sulfuric acid can form, copper sulfate can form sulfuric acid and copper sulfide. Ammonium hydroxide plus iron sulfate will produce ammonium sulfate and iron hydroxide. Sodium carbonate plus magnesium sulfate can produce sodium sulfate and magnesium carbonate. From these reactions, we see that it works for acids, works for bases, and works for salts. So it can be acid with a salt, base with a salt, or salt with a salt. But here there is something that is worth mentioning, and I think some of you might have observed that, and you would ask yourself, we mentioned before in the displacement reaction that sulfuric acid can displace the nitrate, but nitrate cannot displace the sulfate. But here you'd see the sulfur in hydrogen sulfide can displace the sulfate in the copper sulfate to form sulfuric acid. And we all know that sulfuric acid is stronger than H2S, and it is kind of contradicting with what we mentioned before. So this does not agree with what we mentioned. I know that it doesn't agree, but there is some explanation that can tell us why this happens, and this is exactly what I mentioned before. You have forward reaction, you have backward reaction, and the one that is of higher rate will prevail, or will be the reaction that is kind of the output reaction that takes place. And here we have the same H2S reacts with copper sulfate to produce sulfuric acid and copper sulfide, and this should react with this in a higher rate to produce these two. But this doesn't happen. The backward reaction never happens, and the reason it doesn't happen because copper sulfate precipitates and leaves the solution, so sulfuric acid cannot react with it. This means that the reaction cannot go in the backward direction because there is nothing in the solution that sulfuric acid can react with, and this is why the reaction will proceed in a direction that is not the direction that should be going into, because of the absence of the backward reaction, which should be the fastest reaction or the faster reaction. So I hope this makes the point clear. So this is the last reaction that we are going to talk about in this video. The last video in this chapter will talk about the oxidation-reduction reaction. It's kind of interesting reaction, so we'll talk about it in the next video, inshallah. So I'll see you then. Goodbye.